This will be our warm-up. The probability model based on experimental probability for randomly selecting a marble from a bag is P for probability of getting a green is 18 out of 40. Probability of getting a blue is 14 out of 40. And probability of getting a white is 8 out of 40. So about how many marbles of each color are in the bag if there are 60 total marbles? So what we're doing is we're working on proportions. And maybe you don't remember that term, but proportions are when we have a rate or a fraction here, we can expand it on a larger population. Or if we want to, we can reduce it and make predictions on a smaller population. So what we're really doing is finding the probability of getting green is 18 out of 40. Then how many of these green marbles are there out of 60? We're saying, what do I multiply 40 by to get to 60? So what can I multiply 18 by to get to our mystery number? So what we're multiplying 40 by is 1.5. So we're going to multiply 18 up here by 1.5. And that would mean for green, we would have 27 out of 60. We can do the same thing for the blue. It's 14 out of 40. But again, we're trying to get to 60. So we're going to we could set it equal to this, or I can just write a new problem and say, hey, let's compare this to 60. But as far as how we do it, that shouldn't change. We're going to take 40 and times it by 1.5. So we're going to take 14 times by 1.5. And that means for blue, our missing or our expected number would be 21. And then the last one is the white, which is 8 out of 40. Let's project that on 60. Let's multiply that by 1.5, and you'll get 12. Just to double check, if I add up 27, 21, and 12, if we add those all up, you're going to get 60 marbles. So just like if you added up the 8, the 18, and 14, you end up getting 40. So it shows we're using the whole amount. We've kind of just made the group a little bit bigger. Each group got a little bit bigger as we were taking half of that 40 population, which is 20, and increasing it by that half. Hopefully that makes sense.